Hello everybody and welcome. This is our final lecture in the Science and Technology series. Today we will be discussing about energy and we'll be discussing the current things that are going on in the world and India. Alright, so let's move ahead. Before beginning, I would like to give you some brief background about what is going on, especially with regards to India. So India currently ranks as one of the top energy consumers in the world, and with the way our population is increasing and our GDP is increasing, most probably our energy demand will see increase in the next 5-10 years, and it will rise, it will keep rising, and consequently greenhouse gases emissions will also rise. Our population is expected to go from 1.1 billion to 1.7 billion by 2042. This is United Nations estimate in 2017. And if we keep on increasing our population like this, we will overtake China by 2025. And that is also a UN estimate. Now, most of this growth in population will happen in cities. It will not happen in villages, it will happen in cities, because of which urbanization will also consequently increase. And as seen here, it will lead to following demands. We'll see the demands what are given in the image. So what is the result of this? Basically our energy consumption will increase, energy from agriculture will increase, demand from industry will increase, from transport will increase, from cooking, for buildings. Basically energy for construction and manufacturing will also be increasing in demand. And in industry, the demands will be from thermal uses or specific electrical uses in industry. In agriculture, water pumping, tractors. And energy does not just mean electricity. Energy means oil also. In transportation, we will see air transport, railway transport, freight transport, all of these will increase. In cooking, we will see less usage of coal, more usage of LPG, electrical cooking, and so on. In buildings, we will see residential, then hot water requirement, commercial buildings in which offices are there. So all these things will be increasing the demand in the coming years. All right. So please remember this perspective before reading anything related to energy. But if we talk about renewable energy, our progress has been very nice, very good. We have seen a rapid increase in renewable energy sources. For example, you can see from 2013 to 2019, wind, solar, hydro, and biomass, all of those have increased. Most of the growth you will see has happened in wind and solar. Almost same growth is happening in hydro. A little bit of growth is there in biomass, but most of the growth has occurred in wind and solar, and most in solar. So that is what you can see from the graph. So this is also something that you can use in your arguments. So what are the recommendations for overall India's energy sector? Now I'm not talking about any particular energy source. I'm talking about the overall energy sector of India. First of all, we need to keep promoting the energy investments that currently are going on. We need proper regulation. We need proper foresight by policymakers. We need policies that do not change when the government changes. So we need a stable regulatory rules for all players in the market. We need to move toward market pricing for energy commodities. Basically, that means subsidies should reduce. But again, this cannot be reduced for everybody. For some people who deserve, they should be provided with subsidies. Prioritize action to foster energy security. Energy security means that we get the energy that we want and whenever we want. That means we are not basically waiting for another country to provide us with energy. So the central government needs to work with the state governments in order to increase the renewables, and we need to boost the flexibility. We need to improve our emergency oil storage according to the international best practices. We need to create a natural gas market in the country with good infrastructure of gas. Basically, that can be done by increasing supply of LPG, like petrol, piped gas, in rural areas and semi-urban areas. We need to have cross-government framework for energy policy. That means central and state government need to organize things while working together. We need to continue working with International Energy Agency and expand international energy collaboration to benefit from international best practices. This is very important. Of course, India needs to develop, but of course, lot of technologies have already been developed by other countries. We need to see the best practices regarding solar, wind, biomass, hydro, and then develop our sectors, energy sectors. We should not do the mistakes that were done by the other countries. So these were the recommendation for our overall energy sector. Now let's talk about renewable energy. Basically here we will talk about electrical vehicles. So what is an electrical vehicle? You must have heard about this in news a lot recently. Even Tata is coming out with electrical vehicles. Government is also supporting via subsidy. So electrical vehicle uses electrical motors or traction motors for propulsion and not the combustion engine. They use there will be just battery, and the engine will be electrical. It will be just a motor. It will not burn any fuel. It will just get like there is a water pump in our homes, right? We have a water pump. Similarly, there will be a motor in it, and that will run the vehicle. It might be powered by batteries, or it can have solar panels also, or even a generator, so that it can use diesel or some other fuel to generate the electricity. We'll see the type of fuels. So in this, one of the most important technology is fuel cell technology. Now, fuel cell is basically a device that generates electricity by chemical reaction. Very simple definition. Fuel cell is a device that generates electricity by chemical reaction. So if we see what chemical energy it uses the chemical energy of hydrogen. Okay. Now fuel cells can be used in a variety of applications. Like it can be used in transports, it can be used in backup power, it can be used in cars, it will be used in cars, and even at some stage in the future it might be able to power your homes also. All right. Since we are talking about electrical vehicles, in cars, fuel cell can operate at a better efficiency than a combustion engine. That means 1 liter of hydrogen will produce more energy with respect to 1 liter of petrol, right? And they basically do not have any harmful emission also. Fuel cells, right? Hydrogen fuel cells emit only water, so there is basically no carbon dioxide emission, and the pollutants that create smog are because of combustion engines. Also, fuel cells are quieter and basically very quiet, not even quieter than combustion engine. They are just quiet. They produce very low sound and have less moving parts. So it is very good for maintenance. It is very good for environment. Got it? So hydrogen is the fuel, and electricity, water, heat are only the products that come out of that chemical reaction. Fuel cells are very unique. They will be providing fuel for us as large as a power station and as to as small as laptop computer. So they are very versatile. They are very unique. They have zero pollution. They have very less noise. They have very less moving parts. So it is ultimately very beneficial to use. Now fuel cells, let's see this image. Fuel cells will sit in a car like this. As you can see, this will be the fuel cell that will produce the energy, and the battery in the car will store it, and it will basically the battery will keep recharging. All right, and the engine, the place where engine is, there will be the fuel cell, and that will produce the energy on the go. And for emergencies, the battery will be charged. Like nowadays even nowadays, scooties, cars, bikes, they have batteries, right, to start. So almost every vehicle today has a small battery, but that is used only in emergency and it is used for first ignition. But here, this thing, at the place of the engine, the fuel cell will be placed and it will run whenever the car is running, and there will be a battery also in case of emergency or if there is any problem in the fuel cell. So fuel cell will work like battery, but they don't get charged. They run on fuels. They produce electricity and heat as long as hydrogen is provided to them. Now, in fuel cell, there are two. Now, see the right hand side diagram. I am explaining that. A fuel cell has two electrodes, a negative electrode and a positive electrode. Negative electrode is the anode and the positive is the cathode one. Now, between these, there will be a electrolyte. Now, the fuel. Let's talk about fuel, which will be the hydrogen. It will be given to the anode and air is fed to cathode. Now, in hydrogen fuel cell, there will be a catalyst at anode, and it will break the hydrogen molecules into proton and electron. Now that will go to the cathode. These electrons will go to cathode by the external circuit. Now this flow of electrons creates the electricity. So hydrogen will be broken down and the electrons will basically travel from anode to cathode, and that travel of electrons will create the electricity. Now the protons will go through the electrolyte. As you can see the diagram, plus ions will go through the electrolyte to the cathode, and where they will unite with the oxygen and they will produce H2O. Getting the point? So this is how the fuel cell will work. Now related to this is microbial fuel cell. In microbial fuel cell, the membrane, or basically at anode, we will be producing electricity from a bacteria. The fuel will be bacteria and not hydrogen. So it is quite a new thing. So let us see how it works. So Zoological Society of London, they have used plants to power the sensors in the wild, basically in jungle and all, by installing microbial fuel cells. So they have installed sensors in wildlife to monitor them and to power that sensor in the jungle. They are using microbial fuel cell. Now its microbial fuel cell is a bioelectrochemical device, basically biological plus electrical plus chemical device that will use the energy generated by respiring microbes to convert the organic part directly to the electrical energy. Alright, so it transforms the chemical energy into electricity by using oxidation reduction reactions. Now we don't need to go into depth of it, we just need to see how it works from the high level. We don't need to see chemically how it works, that is not the part of our GS. So it relies on living things to facilitate the movement of electrons. Basically, we just need movement of electrons. That in hydrogen fuel cell, it was done by hydrogen. Here it is being done by a living organism. All right. Now, what are the various applications? See, where low power is required and where replacing battery is not very practical, there these microbial fuel cell can be used. For example, the sensors of Zoological Society of London. Microbial fuel cells work by allowing bacteria to oxidize and reduce organic molecules. So this is how they work. Again, I'm telling you, we don't need to go into depth. We just need to know that such thing exists and it converts the basically starts the chemical reaction by biological source. Now, what are the advantages of fuel cell electrical vehicle? I'm not talking about fuel cell now, I'm talking about electrical vehicle powered by a fuel cell. Now, they will produce very low greenhouse gases, and whatever they produce as a byproduct, it will not cause health problems. Now, fuel cells, they emit only heat and water as a byproduct and are more energy efficient than traditional combustion technologies that are there currently. Fuel cell and electrical vehicle do not need to be plugged for charging. This is very important because right now, if you see, let me compare it to the vehicles that are existing right now. Right now, when a car runs, it runs on petrol or diesel or CNG, and it charges that small battery that is there inside the car. Fuel cell will basically provide current to the vehicle or energy to the vehicle like a combustion engine is providing energy to the motor of the vehicle from petrol. So basically here we need energy to rotate the wheels, and that energy currently is being provided by combustion engine. With the fuel cell will replace the combustion engine. That's it. It's not like it is a battery. No, it will actually produce electricity, and with that electricity the motor of the vehicle will run. Of course there will be a backup battery in the fuel cell one also, which will be charged and which will be used in emergency if the fuel cell stops working. And of course we have wide availability of resources for producing hydrogen, so this is very good. What are the limitations of hydrogen fuel cell? So if energy is produced by hydrogen fuel cells, such a clean energy, then why are not we using? You know, why are we not basically producing this on a mass scale right now? See, what are the issues with hydrogen fuel cell technology? The way we need to make hydrogen is mostly through an energy. Basically, we create the hydrogen used in hydrogen fuel cell from electricity, and that electricity comes from fossil fuel. That is the issue. So we need to prepare hydrogen as a fuel, and that hydrogen needs energy. So basically, the process to create hydrogen needs energy, and that is coming from fossil fuels right now. Secondly, safety, because it is quite explosive. If not kept properly, hydrogen is quite explosive. Then there is high surface area carbon. Basically, that you just need to understand that it will corrode the vehicle. Rust will come in the vehicle. Then platinum is used in hydrogen fuel cells, which is quite expensive, and its price is a big barrier in wide adoption of hydrogen technology. So these are the limitations. It is quite explosive, then it is corrosive, it is being produced from fossil fuel sources, and the platinum that is used, it is quite expensive. So let us now come to the central government initiatives on electrical vehicles and what they are doing to promote electrical vehicles. Government of India has set a target of electrical vehicles making up to 30% of new sales of cars and two-wheelers by 2030. So basically by 2030, 30% of whatever is selling, two-wheeler or four-wheeler, it should be electrical vehicle. This is the target set by the Government of India. Then they want to build sustainable electrical vehicle ecosystem, and initiatives have been taken for that, like National Electric Mobility Mission Plan. This was launched way back in 2013, and it wants to achieve national fuel security by promoting hybrid and electrical vehicles in the country. Recently, I sat in a car which is Ertiga, Maruti Suzuki Ertiga. It is a hybrid car. It is a hybrid car. It has petrol plus CNG, and it works very well. Then there is a scheme which is FAME and FAME 2. This is FAME was launched in 2015. It also supports hybrid and electrical vehicle development and manufacturing. This scheme, FAME, is focusing on 4 areas like on technology, on demand creation, new projects, and charging infrastructure. So this is the first scheme. This is the second scheme. Then the third point is organization like Bureau of Indian Standards, Department of Heavy Industry, Automatic Research. They are giving design and manufacturing standards of electrical vehicles, so and charging infrastructure, so that the charging infrastructure is same in, let's say, Allahabad or Prayagraj, and same as Delhi, or let's say Tamil Nadu. So whatever infrastructure is going on in or whatever charging infrastructure is being developed, it should be developed in a way that it is similar, not same but similar throughout the country. Of course, it will then facilitate larger adoption and it will make people's life easier also. For example, you are going on a road trip. So if you go from Maharashtra to Tamil Nadu, then of course you would expect that you will get the same pin, right? Same charging pin, same charging speed. So you will see that okay, these are the stations, charging stations in my way. I will be secure and I will charge my vehicle on the road. So this peace of mind that needs to be there, and that will develop after development of this electrical vehicle charging infrastructure. But again, it has to be done in a way that the standards remain the same throughout the country. For that, central and state government needs to collaborate. So what is the way forward? We need to have affordable, accessible, inclusive and safe mobility solutions in order to increase the ease of living in the country. Ease of living in the country. This is very important because, as I've mentioned earlier, cities will be the next place where population growth will take place. We have to increase the ease of living in urban areas, and right now there are many urban areas. In the next 20-30 years, a lot of new urban areas will be coming. If we start now, if we start good planned development right now, like Chandigarh in tier 2 cities or the suburban cities or satellite cities, then we will be able to give people a good standard of living. They will have high ease of living, and then they can focus on productive things. If we, because it is a fact, a known fact, that many people spend a lot of time in traffic jams and by traveling in unreliable public services. So we need reliable public services, we need less traffic jams, we need more productive time of people, because people will of course work, right? But they, if they are spending 3 to 4 hours traveling daily, which I have also done in my life, so that basically leaves you with no energy to enjoy life, and then of course the happiness index also decreases. So this is all, it is how connected, this is all how it is connected. Then establishing the right coordination among three pillars of the electrical vehicle industry, which is urban planning, transportation and power sectors. Urban planning, if we have good infrastructure, well planned, well spaced infrastructure for charging, people will adopt electrical vehicles. Transportation, we need buses, we need cars that are manufactured, we need power sectors. Basically power sector means we need cheap, cheaply manufactured energy. It basically, at least it should be equal to petrol. Slowly the cost should decrease so that more people adopt the electrical vehicle segment. Then electrical vehicles are a rapidly growing sunrise sector which can give a push to Make in India. So Make in India is a program in which India is envisaged to be uh, basically manufacturing hub of the world. So electrical vehicles are a growing area. So wherever there is a growing area or growing field, India has a wonderful opportunity to become the world's manufacturing bowl. All right. Now let's come to a mission which is India's energy storage mission. This is very careful. This is very critical, and you need to be careful of this word storage. Like I've said before, India's urban population will increase in the next decade. More than 500 million people will live and work and travel in Indian cities. This will give out many social, economic, and environmental challenges. But again, if we are smart enough as a country, we will change these challenges into opportunities by developing new industries, by creating new technologies, by providing employment, by securing our energy and energy security. Now, electrical vehicle is one of the ways by which we can increase the ease of life, like I've mentioned before, and it can help country achieve a lot of objectives, especially environmental objectives and energy security. Because let me give you one perspective. Right now, we import a lot of crude oil, and that is obviously a threat to our energy security. If we are able to create a lot of electrical vehicles in the country and we provide proper infrastructure, proper pricing for cars, proper maintenance, and everything, if we do everything right, then we can become independent, we can become self sufficient. We will import less crude oil, we will only import what is needed, right? And general population will be using electrical vehicles. We can use electrical vehicles in transportation, like trucks and all. They use a lot of diesel, so they can use electrical energy to charge themselves and go on. Of course, battery is not everything. Fuel cell, like we have talked about, they are also very efficient. We just need to solve the problem of their safety. So this is the perspective that electrical energy can make us self-sufficient. All right. Now, storage mission. It is basically the last point that we need to discuss here is domestic manufacturing of lithium-ion batteries which store energy, right? Which is currently the most expensive part of an electrical vehicle. This problem, this lithium-ion battery can be a huge opportunity for India, because if we start making efficient and affordable batteries in India by some, maybe let's say, technological innovation, then of course India will be able to spearhead. Basically, India can lead the electrical vehicle change or electrical vehicle revolution. Because you might not agree with me, but every model of car in the future will have a electrical model. Basically, every car that will come out in next, let's say after next 10-15 years, every car that will come out, it will definitely have an electrical version of it. Getting my point? I'm not saying all vehicles will be electrical. No, I'm saying there might be a petrol version, but there will be a electrical version of that car also. Right now there are petrol and diesel versions. In future, I guarantee you, after 10-15 years, every car in every segment, let it be small car, big car, SUVs, multi-purpose vehicles, pickup trucks, and whatever, so every car will have a electrical version of itself. That I promise you. In 10-15 years, this will happen. Okay. So right now, India is a importer of batteries. If we develop some technology, and I'm pretty sure we can, because Indian people are very smart. They are hardworking. They are studious. They are laborious. So India can do this. We just need to focus. That's it. We just need to focus. We need to provide proper research facilities, incubation, funding, right? Of course, funding is, let's say, the root of every innovation. We need funds to employ smart people. All right. So if we implement all this, we will become a net exporter of batteries, and then we can help other countries to transition to electrical mobility and renewable energy. All right. So basically, like we help other countries in space missions, we can help other countries in electrical storage. Now let us see some issues that are there in the energy storage mission. First of all, India sadly has low reserves, which are of minerals, which are definitely used in lithium ion battery. So because of which, again, we are import dependent. Then early stage manufacturing industry for battery. Basically, India has no major producers of electrical vehicles at present, and creating a state of the art manufacturing unit will take a lot of time. And if we start developing things now, then we will develop a good industry within 5 to 10 years. But again, there are many countries who are already ahead of us. So this is a problem which we need to solve. Then there is lack of coordination among various stakeholders. Like there are various stakeholders in the battery manufacturing, like the person or the people who supply the materials. Then there are manufacturers, then there are vehicle okay, then there are battery manufacturers, then there are vehicle manufacturers, then there is local, basically the state government and the central government, then there is research institute which will research into battery technology. So there are a lot of people who are involved in this technology, and sadly there is lack of coordination. If we can coordinate well, then the 2030 EV target will be achievable. Then there is high perceived risk. Why? First of all, because of the lack of coordination. So due to the uncoordinated effort and low mineral reserve, and we have very less good manufacturers in India, this sector is perceived quite risky in terms of investment. So some concrete issues are there which we need to solve, and if we can solve them, we will get ahead of the world. If we can't solve them, at least we should minimize the issues that these points are creating. All right, so quite an important mission, quite an important topic. Please do revise this. Next, we come to the second topic, which is nuclear program in India. India has a three-stage nuclear program, and it was created by Dr. Homi Bhabha. And it wants, basically the plan, this three-stage program, it wants to utilize the limited uranium resources that we have, and the abundant thorium reserves that we have. So we want to create a balance, and we want to create a process in which we start from uranium but we end up with thorium, because India has a lot of thorium resources. So this was formulated by Dr. Homi Bhabha in the 1950s to secure long-term energy independence of India. So very important keyword, long-term energy independence. So in the stage 1, we will build pressurized heavy water reactor. Stage 2, we will develop fast breeder reactor. Stage 3 will develop breeder reactor. Now why 3 stages? Although we have 25% of the world reserves of thorium, but itself, by itself, on its own, it's not a fissile material. We need to change it. We need to transmutate it to uranium 233 in a reactor, in a nuclear reactor. Now this three-stage program is based on a thing called closed fuel cycle. Closed fuel cycle, because in these 3 stages, the fuel that is used in one stage is reprocessed to produce fuel for the next stage. Basically, output, or the basically stage 1, we'll see that in the next diagram, that output can be used in the next, oh sorry, as the input in the next stage, then its output will be used in the next stage. So like this. So let us see what I just talked about. Pressurized heavy water reactor, this is the first one. So output is plutonium. Now the plutonium in the second stage will be used with uranium to produce U-233. Now this U-233 from the second stage will be utilized with thorium to produce energy. This is the thing. So you can see the flow like this and like this, right? So this is the very interesting thing about India's nuclear program, quite a unique program in which the resources, the plan was made according to the resources that we have. Now let us briefly see what are the challenges in the three-stage program. First challenge is safety and waste management. This is a challenge in every nuclear technology. Incidents like Chernobyl, Fukushima are serious cause of concern. If we generate nuclear energy and we follow the highest safety measures, there is less possibility, but still some accident will happen, and it has happened. But again, these are very few in numbers, and most of them happened because of the error of humans rather than the reaction, the nuclear fission reaction. So rather than the technology, it was the fault of humans in most of the accidents, because a lot of research is done before installing a nuclear reactor, like earthquake and environmental things. A lot of things are taken care of before even thinking of establishing a nuclear power plant. Next is availability of the fissile material is also a cause of concern, because nuclear fuel is not available easily in the world. It needs a lot of diplomatic efforts, like US India nuclear deal. Third point is land acquisition and selection of location for nuclear power plant is also a major problem in our country. For example, we had seen this problem happen in Kudankulam in Tamil Nadu, where it was delayed by lot of time because of the land acquisition challenges. Fourth point is, as India is not the signatory of NPT and NSG, the nuclear supply is constrained by sanctions against India. But the situation has changed after 2009 waiver and bilateral civil nuclear energy agreement with many countries. So right now things are quite good, because India has such a clean track record. India does not produces nuclear power or does not misuse nuclear power to threaten other people. Whatever India does, or whatever tests that India had done earlier, they were to establish India as a nuclear power. India did not want to destroy any country. India just wanted to protect itself. That is why in 2009 a waiver was given to India, and lot of fuel was given to India. Also, reprocessing and enrichment capacity needs a boost in India, because the fuel cannot be used like it has to be refined, it has to be reprocessed and enriched. All right, so India needs advanced technology to enrich and reprocess the spent fuel. So that is a challenge that we need to improve it. It's a challenge right now. So what to do? What is the way forward? What are the solutions? Now, to ensure the safety and security, which we talked about that it's an issue, we need to have good skilled engineers, and we need to have excellent regulation, top of the line, cutting edge regulation. Secondly, we need to foster, or we need to create facilities for waste disposal and management, because nuclear energy has one concern, which is the biggest concern, is the safety. Second is the waste disposal of the nuclear fuel which is generated, or the nuclear waste which is generated. So this is very important, and we need international agreements to get the technology for waste disposal and management. Then third point, that India needs to create nuclear energy as a sustainable energy source, because nuclear technology is the future. And like Germany has shifted totally to nuclear energy, almost to nuclear energy, and they use very less fossil fuels. Similarly, we need to do this for the sake of our country and sake of our energy security, sake of our world. Then we need to maintain and reinforce international non-proliferation agreements, basically so that the fuel that is used by the countries, they do not use it for weapons. We need to use nuclear energy only for civilian purposes, and to increase the production of energy in the world. Got it? So all these talk was for nuclear fission. Now we'll talk about very interesting thing, which is based on nuclear fusion. All right. So this project is called International Thermonuclear Experimental Reactor. Experimental reactor. It's not something which is abundant in the world right now, but again we are trying to develop a reactor which is experimental based, basically a pilot project for nuclear fusion. Got it? Nuclear fusion, not fission. I hope you understand the difference between them. So ITER is a collaboration of 35 nations, launched in 1985. It is located in France. Now this project wants to build the largest tokamak uh, it's a reactor type to prove the feasibility of the fusion, nuclear fusion, as a carbon-free source of energy. Now, nuclear fusion is the energy by which, or sorry, nuclear fusion is the reaction by which sun produces the energy to sustain life on Earth. Now, what is tokamak? Tokamak is basically a machine which will be used to create nuclear energy fusion or nuclear fusion's energy. Now, inside the tokamak, the energy is produced through fusion of atoms and the heat is absorbed in the wall of the reactor. Now, we will use this energy to produce steam, and by the steam we will rotate the motors and generate electricity by turbines and generators. So this is how it will work. It will heat up, so there will be a reaction, there will be reaction here, fusion here, it will heat up the wall, then we'll produce steam by throwing, basically utilizing the heat and heating the water and producing steam, and then we will rotate the turbines and generators to produce electricity. So this is how it will work. Now, officials say that this reaction, this nuclear fusion reaction, will be the most complicated machinery ever created by humans. It will have very big, almost the world's largest superconducting magnets, because a lot of basically we need a very strong magnetic field to contain the plasma, because the temperature, plasma is one of the state of the matters we discussed in Bose-Einstein condensate. So plasma will be generated because the area will reach the temperature like 150 million degrees Celsius, basically even 10 times hotter than the center of the sun. So the air around will turn into plasma, and we need very strong magnets to keep or contain the plasma. So this is how it currently looks. It is being developed in France. All right. Now, what is the contribution of India? India had joined this project formally in 2005, and it is responsible for delivery of lot of components like water system, cooling water system, cryogenic system, and so on. We don't need to know that. We just need to know that India had joined it, and India is contributing around, or the effort that India is giving, it is around, in monetary value, it is $2.2 billion. Now, ITER India is the Indian domestic agency, which is a specially powered project of India's Institute of Plasma Research. This is an organization under Department of Atomic Energy. So we have taken significant steps to join this organization, because nuclear fusion, if it is harnessed, it will change the world. It will lead to unlimited energy. Just imagine we have a small sun with us. If we are able to produce proper energy safely, because nuclear fusion, it's dangerous because you can't stop, basically you can't control it. If you can control it, but it's very difficult to control. Nuclear fission is very easy to control. So, and as you saw, that temperatures also reach to 150 million Celsius. So due to which, basically nuclear fusion is very powerful. All right, and we need to create a lot of precautions to control it. So this quotation is there on the, or this line is there on the ITR site, the site of this project. It says, fusion, the nuclear reaction that powers the sun and the stars, is a potential source. Remember, potential source. It is being researched, it is being worked upon. It is not currently a viable source. So it's a potential source of safe, non-carbon, virtually limitless energy. Harnessing fusion's power is the goal of ITER, which has been designed as a key experimental step between today's fusion research and tomorrow's fusion power plants. So this machine which is being created right now, it's an experimental reactor. If it works, then fusion reactor power plants will be created in the next 50 years. So if we can crack this fusion energy, we can get a huge carbon-free energy. What are the advantages? So before moving on to advantages, I'd like I talked that our sun has or our sun works on fusion energy, and without fusion we won't have a life on Earth. All right. So in fusion reaction, the hydrogen nucleus collides, it fuses into heavier helium atoms, and this releases a lot of energy. All right. Now, due to billion of years of evolution, the gravitational forces led to formation of stars, right? So that is just something as a history of fusion. Just 2 3 lines. Anyways, coming to right now climate change is a very important concern. We also have finite sources of fossil fuel. We don't have unlimited sources of fossil fuel, right? It's a non-renewable energy. So we need better ways to meet the demands of population and energy needs that will come in the future. Got it? So this is why we need fusion power. Now what are the advantages? No carbon emission. The only byproduct will be helium, and which is an inert gas. It will not harm the environment. Fuel is available a lot because deuterium, which is basically hydrogen, this can be extracted from water, and tritium will be produced inside the power station from lithium. So lithium is basically quite readily available in on Earth, and even after the adoption of fusion power, these supplies will last for thousands of years. So supply of deuterium and lithium, it will be supplied for thousands of years. So we have abundant fuel. I mean, this is not a joke. So we right now have uh, finite non-renewable fuels, but we have abundant fuel for thousands of years for fusion. Now the most promising hydrogen fusion reaction is the fusion of deuterium and tritium. That is why we have talked about these two only here. Efficiency in the production of energy. 1 kg of fusion fuel will give same energy as 10 million kilograms of fossil fuel. Just imagine 1 kg of fusion equal to 10 million, basically 10 lakh kilograms. Oh, sorry, 100 lakh kilograms of fossil fuel. A 1 gigawatt fusion power station will need less than 1 ton of fuel during years operation. So it's just incomparable. The energy efficiency is just incomparable. Fusion wins all the time. Now it is less radioactive than fission. There is basically no radioactive waste because what is produces helium, right? So a small thing that becomes radioactive, that can also be reduced based on the material that is used to build the reactor. About safety. Now in fusion, large scale accident is not possible because the fuel use is very small. So we can anytime remove the fuel, or we can have safety features which can immediately within seconds stop the fuel from working basically. Then reliable power. Why? Because fusion power plants will be designed to produce a continuous supply, so it will be very reliable source of supply. It will go on in future, and once the technology is developed slowly, obviously in the next 50 years, 30 to 50 years, cost will obviously be lesser because the fuel needed is very less. So problem is not of fuel, problem is of developing and controlling the temperature that is produced. Got it? So what is the perspective? Now this is the last topic of our series. After this, our science and technology series will be over. So what is the final perspective of this topic? By the end of this century, energy demand will easily triple or even increase by 4 times because of population, because of urbanization, right? So developing country will also develop, and they will demand electricity for their areas. So relying only on fossil fuel is not a smart strategy for the future. We need to increase the energy production and we need to increase it in a environmental friendly way. We need to have some practical alternatives to non-renewable energy. And of course, a lot of countries do not have the fossil fuels like us. We import our crude oil. So that is why this project becomes very important for India also, right? So fusion energy is a great opportunity for India to meet its energy needs in the future. Of course, India is already working on a lot of fission reaction nuclear power plants, but this fusion reaction, if it is developed, can make countries very independent and of course the world independent from fossil fuels. So although fossil fuels have brought us till here, going into the future, we need nuclear fusion energy. Not even fission, we need fusion energy. Because if that is achieved, limitless energy can be created. Alright. Alright, so that is all for this lecture. It was a pleasure teaching you all. I hope you had fun learning some things and it was helpful for you. Right, so my name is Shitish Dhiman. It was a pleasure teaching you all. I hope we meet again in some series. Good luck with your studies. Please do revise. Without revision, whatever you read, it's not going to help you. If read only if you can revise. This is very important. If there is one thing which I would like to tell you is about revision. Even if you practice MCQs, practice answer writing, even then you have to revise what you did, revise what you learned. You should make notes of the answers that you get from MCQs, especially from the MCQs which you solve incorrectly. So revision is imperative. Without revision you will not get anywhere. It is very important, and I wish you good luck with your future, especially with Amrita, and I hope you get what you need. And my name is Shitish Dhiman and it was a pleasure teaching you all. I Let's hope if we meet again. And chalo, till then, take care everybody. As usual, bye bye and be well.